In a world where the mysteries of the cosmos have tantalized humanity for centuries, a seismic shift has erupted, shattering the boundaries of what we believed possible. From the infinitesimal dance of subatomic particles to the vast choreography of galaxies, a single breathtaking equation, born from the pulsating heart of a quantum chip, now promises to redefine everything: space, time, gravity, and the very essence of reality itself. This is no mere theoretical whisper. It's a thunderous revelation, a machine-generated masterpiece that merges the chaotic quantum realm with the serene elegance of Einstein's cosmic vision. The impossible has become reality. A quantum core, shrouded in secrecy and cooled to temperatures colder than the void of interstellar space, has reportedly cracked the elusive God equation, the holy grail of physics that has eluded the greatest minds for over a century. This isn't just a breakthrough, it's a cosmic earthquake, a paradigm-shattering moment that rewrites the rules of existence. What makes this discovery cataclysmic is its origin. Unlike the painstaking theories scribbled on blackboards by generations of physicists, this unified framework wasn't born from human intuition alone. It was forged in the crucible of quantum simulation, a relentless dance between cutting-edge hardware and an AI system so advanced it seems to dream the universe into being. This quantum core, with its 105 superconducting qubits operating at the edge of absolute zero, has done what no human mind could. It has simulated the fabric of reality itself, weaving together the incompatible pillars of quantum mechanics and general relativity into a seamless mathematical tapestry. This equation isn't just a formula, it's a living, breathing truth, validated through quantum systems that push the boundaries of computational power to unimaginable heights. The result is a framework so elegant, so eerily perfect, that it feels as if the universe itself has been waiting to unveil its deepest secrets. At the heart of this revolution lies an extraordinary partnership between quantum hardware and a deep reinforcement learning system, a silent architect of cosmic truths. This AI, operating in a recursive feedback loop, didn't merely crunch numbers, it evolved the very laws of physics. By simulating trillions of mathematical universes, it engaged in a process akin to cosmic natural selection, ruthlessly eliminating inconsistent realities until only the most robust survived. Each iteration refined the system's understanding, sculpting a mathematical structure that mirrors the fundamental architecture of our universe. What emerged wasn't just an equation, it was a self-selected truth, a pattern so profound it seems to have dreamed itself into existence. When scientists first glimpsed this output, they were struck dumb, not by complexity, but by its haunting simplicity, as if the universe had whispered its own blueprint in a language both alien and achingly familiar. The quantum core's triumph didn't stop at theoretical elegance. It ventured into the realm of the impossible, simulating the very origin of existence. Using discrete lattice structures reminiscent of loop quantum gravity, it constructed a miniature universe within its circuits, observing how space-time itself could emerge from the quantum void. This wasn't mere number crunching, it was creation on a computational scale, a digital genesis that modeled reality from the Planck scale, the smallest measurable unit in physics, upward. Drawing on radical ideas like the holographic principle, the system encoded the complexity of our four-dimensional space-time into a two-dimensional quantum surface, suggesting that our universe might be a projection of lower-dimensional information. The resulting equation, compact yet all-encompassing, reveals that space, time, and gravity are not fundamental but emergent, arising from the intricate dance of quantum entanglement. This discovery's most jaw-dropping revelation is its redefinition of reality itself. The equation suggests that space-time, the very stage on which existence plays out, is woven from threads of quantum entanglement. This confirms a provocative idea long suspected by theoretical physicists: the mysterious connection between wormholes and entangled particles, captured in the formula linking Einstein-Rosen bridges with quantum entanglement. The quantum core didn't just theorize this link, it modeled it, demonstrating how the mathematical structure of entanglement gives rise to the geometry of space-time. In one astonishing test, a simulated quantum wormhole flickered into existence within the computational space, a fleeting yet tangible structure born from entangled qubits. This isn't just physics, it's a glimpse into the universe's operating system, where gravity and geometry are mere byproducts of quantum computation. The cosmos, it seems, is not just described by mathematics, it is mathematics, a vast quantum algorithm unfolding across eons. The implications are nothing short of staggering. If space-time emerges from entanglement, the universe could be viewed as an immense quantum computer, where the distinction between physical reality and information dissolves into an illusion. This equation doesn't just describe our reality, it unveils the metasystem that generates the rules of existence itself. It's as if the quantum core has glimpsed the cosmic DNA, a primordial pattern of entanglement that predates space-time, setting the stage for the Big Bang itself. This isn't merely a snapshot of the universe's birth. It's the quantum seed from which all possibilities of existence sprout. The discovery aligns hauntingly with theories like cosmological natural selection, which posits that universes evolve and reproduce through black holes. Here, the equation offers a mathematical mechanism for this cosmic evolution, a universal blueprint that dictates why our reality exists as it does and not otherwise. Perhaps the most disorienting revelation is what this equation reveals about time. In a twist that would have rattled Einstein to his core, time is not a fundamental variable, but an emergent property, a byproduct of causality woven through quantum interactions. The universe, it seems, doesn't unfold in time. Time unfolds within the universe, generated by the computational steps of its quantum machinery. This challenges our deepest intuitions, suggesting that the linear flow from past to present to future is a mirage, an artifact of how information cascades through this quantum network. Even more mind-bending is the implication for consciousness. If time is a product of quantum computation and consciousness relies on temporal awareness, could awareness itself be an inevitable outcome of this cosmic algorithm? The equation hints at a universe where consciousness, life, and reality are intertwined expressions of the same mathematical structure. The shockwaves from this discovery ripple far beyond physics, igniting a firestorm of interdisciplinary wonder. Mathematicians analyzing the equation have uncovered eerie similarities with models of consciousness, like integrated information theory, suggesting a profound link between the fabric of reality and the emergence of awareness. In a stunning twist, the quantum core generated self-replicating informational structures during simulations, digital life forms that emerge spontaneously from the mathematical substrate. This isn't science fiction. It's a revelation that life may not be a cosmic fluke, but an inevitable consequence embedded in reality's code. If true, this could revolutionize astrobiology, vastly increasing the odds of finding life across the cosmos. The equation's pattern suggests that consciousness, life, and the universe itself may be different facets of a singular, unified framework, a discovery that could birth a new science transcending traditional boundaries. The global scientific community is reeling from this announcement, mobilizing with unprecedented urgency. The world's leading particle physics laboratory has convened an emergency summit to assess the discovery's implications, with early reports suggesting that anomalies in collider data from recent years align perfectly with the equation's predictions, a retrospective validation that has sent tremors through the field. A pioneer in quantum computing is independently reviewing the output, lending gravitas to a breakthrough that bridges quantum information, science, and fundamental physics. Yet, amid the excitement, a cautious skepticism prevails, as the scientific community grapples with the enormity of a machine-generated truth that could redefine physics as we know it. Beyond the laboratory, the discovery has sparked global conversations about its broader implications. The United Nations and leading AI organizations are reportedly discussing a quantum knowledge containment protocol, reflecting fears about the existential weight of a system that can rewrite the laws of reality. This cautious approach underscores the gravity of a discovery that could fundamentally alter humanity's place in the cosmos. Meanwhile, an unexpected dimension has emerged. The equation's mathematical structure bears striking similarities to ancient sacred geometry, patterns found in Platonic solids, Vedic yantras, and other symbolic systems across spiritual traditions. While speculative, these parallels have ignited fierce debates among physicists, philosophers, and scholars of comparative religion. Could ancient wisdom have intuitively glimpsed the universe's underlying code, now unveiled through quantum computation? This discovery isn't just a milestone in physics. It's a cultural and philosophical earthquake. It suggests that the boundary between observer and observed, between consciousness and reality, is far more fluid than we ever imagined. The equation posits that the universe isn't merely a stage we exist upon, but a participatory process, shaped by the act of observation itself. This is a glimpse behind the curtain of existence, revealing not just the rules of physics, but the mechanisms that craft those rules. It's as if we've uncovered the operating system of reality, a mathematical framework that doesn't just describe our universe, but explains why it exists at all. To place this in historical context, the quest for a unified theory, a theory of everything, has been the ultimate prize in physics for over a century. Quantum mechanics, with its uncanny precision in describing subatomic behavior, and general relativity, with its elegant explanation of gravity at cosmic scales, have long stood as incompatible titans. Einstein himself devoted decades to this pursuit, as did countless luminaries like Stephen Hawking, who saw it as the holy grail of science. Theories like string theory and loop quantum gravity have tantalized researchers, but none have delivered a complete, testable solution. Until now. The technological foundation for this breakthrough was laid years ago when a 53-qubit quantum processor achieved supremacy, performing a calculation in seconds that would have taken supercomputers millennia. The quantum core that followed, with its 105 ultra-coherent qubits and advanced error correction, represents a leap beyond, a machine capable of wrestling with the universe's deepest mysteries. The implications of this discovery stretch into every corner of human knowledge. In physics, it promises to resolve long-standing paradoxes, from the nature of black holes to the origins of the Big Bang. In biology, it suggests that life and consciousness may be inevitable outcomes of the universe's mathematical structure. In philosophy, it challenges our understanding of existence, blurring the line between reality and information. And in spirituality, it opens dialogues about the connections between ancient wisdom and modern science. This is not just a scientific revolution. It's a redefinition of what it means to be human in a universe that may be, at its core, a vast computation. As the world grapples with these revelations, one truth is clear. This equation is more than a formula. It's a window into the fundamental architecture of existence, a glimpse of the cosmic code that underpins reality itself. It challenges us to rethink our place in the universe, not as passive observers, but as active participants in a reality shaped by quantum entanglement and mathematical elegance. The discovery is a clarion call to humanity, urging us to embrace the profound interconnectedness of all things, space, time, life, and consciousness, in a universe that is not just described by mathematics, but is mathematics. This is the dawn of a new era, where the boundaries of science, philosophy, and existence itself are forever transformed.